we are continuing to look through this open-ended task. Hopefully you're having as much fun as I am. Okay, so we've looked at the scatter plot, we've described it, and we've explained any implications. We then looked at the residual plot, we've described it, and then also explained any implications. So we've confirmed that we have non-linear data. So if the data is non-linear, test all transformations and select the best one to transform the data. Okay, so that is our next step. We drew the scatter plot, we saw that it looked nonlinear, so we confirmed it by performing a residual plot. Now that we've confirmed that it is nonlinear, we're now going to perform some transformations to make it linear. Now, it says that we need to test all transformations and select the best one to transform the data. Now, we're not going to try every transformation possible. Rather, what we're going to do is we're going to use this right here. We're going to use our circle of transformations and say, well, which of these best looks like our data, and that will allow us to figure out what transformations we should be using. So let's come over here. And as you can see, it's kind of curving this way. So therefore, we're going to be looking at these transformations because our data looks like this. So to linearize it, we're going to use these possible transformations to make it more straight. So we're going to have to go about that now. And if we come to this page, we can go through a whole bunch of these transformations and then figure out which of them will give us the straightest line. And we can figure out which of them is going to give us the most linear line by looking at the R value provided. So let's go through all these transformations and go about it. So remember, these are the transformations that we're going to use: y squared, log of x, and 1 of x. And that's because this looks most like our data. So we've already figured out the R value for the original. If we come back here and we go back here, you can see the R value of our original was 0.8249 with a bit of rounding. 0.8249. When it comes for your original SAC, it will be very clear based on what we give you as to how many significant figures or just how many decimal points we want you to round to. So for this one, we're kind of just going to 4 decimal places, but come your actual SAC, it'll be very clear what you have to round to. Okay, now looking at our circle of transformations, the next one that I'm going to do is leave GDP. So I'm just going to leave that as is, but now I'm going to square my Y value. So LE squared. So that is this one right here that I'm doing. So let's do that. So let's come over here. And as you can see, I haven't left myself enough room because I need to square all these data points. And this at the moment is in the way because what I really want to do is just perform all my transformations next to each other. But right now this is in the way. So what I'm going to do is I'm going to go up, up, up on my keypad. If I just go up, I can just delete that and I can delete all of that. So if you come to the very top one and you do that, it then gives you the option to delete everything. Okay, let's come here and let's type in LE and I'm just going to put LES. That's what I'm going to call it, which is going to stand for life expectancy squared. I then come to this one, I go equals, then I go variables and I can go LE, or maybe it's quicker for you just to type in the letters LE, then we're going to square it, we're going to hit enter. That is something that we need. The next one that we need is when we log the X variable. So if we come over here, we can go log of the GDP. So log of X, and this one remains the same. So now if I come over here, I'm going to come here, I'm going to go, all right, I'm going to log the GDP. And maybe there's a quicker way for you to write that. Maybe just write LGDP because, you know, that's really all you need. You don't want to be wasting too much time labeling things, but you still need to make sure that once you look at it, you can see what it is. So the log of the GDP, I come here, I go equals, I go variables. I'm taking, now this is where I have to be careful actually. I'm first going to go log. Oh, that's not log. Control this one. I don't have to put 10 there. The CAS assumes that it's going to be 10. Then I can put in my GDP there. I hit enter and that fills all of that out for me. And then the last one that we have to do is the reciprocal of the X. So I might just call this R for reciprocal GDP. Then we come down here, we go equals, then we go 1 divided by, then I go variables and I go GDP and then I hit enter and all of that is filled out for me there. Perfect. So all that information is there for me. Now I can go about and I can perform my statistical analysis on each of these and just make sure that you're careful with each one. Okay, so let's come over here. And the first one that we're going to do, and actually, let me write this in here. What I did for that last one is I went 1 over the GDP and I left this unchanged. Okay, what I now need to do is perform a statistical analysis on each of these transformations to figure out which has the highest R value. All right, so we go menu, we can go statistics, we can go stat calculation, and we can go linear regression, A plus BX, that's the one you want to use. Then we're going to go here, we're going to go GDP. Actually, yes, for the first one, I want to go GDP. And then I'm going to go the least square regression squared. So that's my y squared one. We hit OK. And then you can see that the R value for this one is going to be 0.8477. 0.8477. And seeing here, my fifth decimal point is 3, so I don't have to round it. So, well, I do round it. It just goes to 7. 0.8477. And now, the next one that we're going to look at is the log GDP versus LE. So we come over here. Whoopsie daisy. Cancel. I'm going to put it here this time. Menu, statistics, stat calculation, linear regression, A plus BX. We come here. We go to GDP. Actually, I want log GDP rather, LGDP. LE stays the same for this one. We go OK. And now we scroll down. My R value for this one is 0.95261. So I'm just going to write 9526. See how this one is much better, 9526. That means it's a more linear line because I've got a higher R value. But let's not get ahead of ourselves. Let's now try the last one, which is the reciprocal of the GDP versus the LE. So we come, I keep doing that. Whoopsie daisy. Just hit escape just to get rid of that. Escape, sorry. There we go. Come over to our next one. We go menu, statistics, stat calculation, linear regression, A plus BX. This time I'm going the reciprocal of the GDP versus my life expectancy. I hit OK. And that's going to give me an R value of negative 0.853. And I do not have to round that. So it's going to be negative 0.8753, just like that. Now, which of these has the highest R value? When I'm saying that, I'm saying which one is closest to 1 or negative 1. Because if you look up at our little scale here, as we were talking about before, you know, it's both strong if it's really close to negative 1 or really close to 1. So what is closest to negative 1 or 1? So if we come here, you can see that the one that is the best is this one right here. You might be asking yourself, why is the reciprocal of GDP negative? And remember, when you find the reciprocal of something, the gradient changes. And that's why you've got a negative value there. The gradient of the line changes. But this is our best one here. So I'm going to write here, the strongest transformation is going to be the log of GDP versus the life expectancy. That looks like us. Let's try that again. Versus the life expectancy. That is the strongest because it has the highest R value. And then we continue on from here. So it's asking us to transform the data now and comment on what it looks like. Again, you're not going to be asked to draw a scatter plot. It's going to take too long. So you're not going to be asked to draw the scatter plot, but you might like to draw it in for your own reference later on. But let's now come here. Let's come back here. And I'm actually going to get rid of my residual plot here because I don't need to look at it for the time being. Let's hide residual plot. And let's now change the GDP to the LGDP. And as you can see, it is more linear. Now we need to comment on it. So the relationship between the log GDP and the LE is strong, positive, and linear with no obvious outliers. So it's strong because the R value is telling us that. It's positive because you can either just look at the gradient or just see the fact that your R value is positive. And now, most importantly, it is linear. Also, make sure that you're saying it's the log of the GDP, not just GDP anymore. And there are no obvious outliers here. Having now done that, we need to confirm that it is actually linear. And the way that you confirm whether something is linear is by doing what? The residual plot. So you don't have to draw it. Again, in the SAC, they're not actually going to get you to draw it, but you might like to just put in a real rough draw of it just so you can see it for your later reference. If we come back here now, we can go menu, we can go analyze, we can go residuals, and we can go show residual plot. And as you can see now, it is random. Before we saw a clear pattern, but now it is random. So if we come over here now, we're going to comment on our residual plot and draw some conclusions from it. We can say that the transformed data residual plot has no obvious pattern. Conclusion, the transformation has been successful at linearizing the data. We can now make predictions. That is the conclusion that we can now make. It is now linear, so we can make conclusions from it. Before we move on, let's just look at the questions here to again get a sense of where we've been and where we're going to soon head. We began by looking at the scatter plot of the original data plot. We described it and described any implication. The implication being it looks nonlinear, therefore we need to do a residual plot of it. We then looked at the residual plot, we described it and explained any implications. The implications this time was that this is truly nonlinear because there's a clear pattern in our residual plot, therefore we need to apply some transformations. We therefore applied some transformations to make the nonlinear plot more linear, and we selected the best one to transform it. That's when we went through all the different linear transformations, or the different transformations based on this, compared the R values to see which one was the best. We then complete the transformation and then give the least square regression line in terms of the correct variables. That's where we're going to head soon. That's going to be step number 4 when we actually write down the least square regression line of our transformed data. But I'm going to pause here before we do that, and I'll see you in that next part where we're going to draw our least square regression line. I'll see you soon.